Okay, so we're going to take a look at another question from the 2023 HSC Standard 2 Maths paper. This is question 19. So if we have a look here, we're told a network of running tracks connects the points A, B, C, D, E, F, G, H as shown. The number on each edge represents the time in minutes that a typical runner should take to run along each track. A, which path could a typical runner take to run from point A to point D in the shortest time? All right, so here we could use a shortest path algorithm, something like Dijkstra's algorithm, to find the shortest path connecting nodes or something along those lines. Because it's quite a small diagram, we could also just check a few paths. So we're going to pick some obvious paths. We'll pick some outside paths, A to B to C to D. So this is 3 plus 11 plus 9, that's 23. We could have A to H to E to D. This is 6 plus 7 is 13 plus 15 is 28. We could have a middle path that sort of goes through the center, A to F to G to D, A to F to G to D. 5 plus 5 plus 5, that's 15. So 15 looks like the best path so far. However, if we notice at the start, instead of going from A to F, we could go from A to B to F, and that's slightly faster. We could instead have A, B, F, G, D. This is 3 plus 1 plus 5 plus 5, which is 14. And you can sort of keep checking paths in this way. You can find paths that are short, then see if you can shorten them by changing them. This can be done manually in this type of question. It doesn't take you too long to find what the shortest is. And in fact, the shortest is A, B, F, G, D. And its length is 14. So this is the answer here. To get 1 mark, you'll need some path that connects from A to D. So find a path, say its length, find a few paths, say their lengths. To get the second mark, you'll need the shortest path, which is A, B, F, G, D, which is 14. And you could do this with an algorithm if you want, or you could do it manually. This way, not without the algorithm, is really nice in this case. Now part B, we're told a spanning tree for the network above is shown. Is it a minimum spanning tree? Okay, so we're going to find the length of the minimum spanning tree in the diagram. The length in the diagram is 3 plus 11 plus 1, that is 15, plus 2 plus 4, that's 21, plus 5 plus 5, that's 31. So what we're going to do is we're going to find a minimum spanning tree on the diagram ourselves, and we're going to compare the length of the minimum spanning tree we find with the length of this one. If they're equal, then it is a minimum spanning tree. If they're not, and the one we find is less, then it is not a minimum spanning tree. So we'll start at point A, then we'll take the shortest path away from A. Well, that will go 3, get us to B. Take the shortest path away from either A or B without closing a loop. That will take us to F. Take the shortest path away without closing, gets us to H. Now we could take this path down to get to E. Now we could go 5 to get to G. We could go 5 to get to D. And then the only one left is C. We could go up by 9 to get to C. So this is going to be a minimum spanning tree. The minimum spanning tree length we found is 3 plus 1 plus 2 plus 4. Well, that's 4 plus 6, that's 10. Plus 5 plus 5, that's 20. Plus 9, that's 29. So when this question asks us, is the tree listed in the paper a minimum spanning tree? No, because the minimum spanning tree has length 29, not 31. So this is the only reasoning we need. The tree in the paper is too long, and therefore it's not the minimum spanning tree. So for 1 mark, you draw some kind of spanning tree or some kind of minimum spanning tree or something like that, some equivalent merit. For the second mark, you will need a justification for the answer. So you'll need to have found a correct minimum spanning tree or some equivalent using graph theory, and then you'll need a statement showing why the tree you found is actually the optimal tree or not. So this is how we do question 19 from the 2023 Standard 2 Maths paper.